Right, so another is straightforward. So they're asking about the chlorine radical, free radical substitution mechanism of chlorine. So basically here, this was the initiation step. It will produce two chlorine radicals. So when you have this chlorine radical, it will attack basically CH4. So here they are asking which of the following steps correctly represents, okay, correctly represents a propagation step. So these all steps can be there, but first steps is formation of the chlorine radical, which is called the initiation. And when you have this chlorine also, it can be again recombined to form Cl2. So this is basically termination. And they are asking about the initiation step. So when you have this CH3 radical forming in the propagation step after the attacks, for an example, if you have CH4, okay, initially this Cl radical will attack, and there can be this CH3 radical that is formed in the propagation step, and additionally there will be HCl that is forming. So then this CH3 radical, okay, so understand what I'm going to tell, right? So then this CH3 radical can be attacked by both Cl radical or Cl2. Think about this, what I'm telling, right? This CH3 radical that is formed after the first propagation step, this is the first propagation step, this CH3 radical can be attacked by either Cl radical, same here, to form what? CH3Cl, right? Like this. But this CH3 radical also can be attacked by a Cl2 molecule like this, right? Forming again CH3Cl plus Cl radical. Okay. Now tell me which step is going to happen. You can use the chat box to answer to my question. Okay. Because this is the first step of the propagation step. When this is happening, CH3 radicals will form, and these CH3 radicals can be attacked by either chlorine radicals, which were already present here in the mixture, or even Cl2 radical. So which of these steps can happen, and what is your idea about that? So that means the last one. Okay, so what about others? So I have one answer. So what about others? What do you think? Okay, so I have another one. So it also says the last one. Okay, so I will clarify what I am telling. So basically try to understand, okay? So here you can see CH3Cl is formed in both occasions, right? So this is a step that provides you CH3Cl in the mixture, okay? But identify these two steps. These two steps are different steps. For an example, this last step is a propagation step, right? I will tell why it is propagation later. So this is propagation. And this second step, this is termination step. Okay. Because when you have CH3 radical that is formed and when you have Cl radical that is formed from the initiation step, these two can combine, like the second step, these two can combine and form CH3Cl. So basically in the mixture to form CH3Cl, there are two methods. One is from the propagation and one is from the termination. Don't forget that. But this propagation step here becomes the prominent one. Okay. Why? Because in the mixture, you have higher Cl2 concentration than Cl radical concentration. Okay, don't forget that. Because in the mixture, there is higher Cl2 concentration than Cl radical concentration. Because Cl radicals are formed after chlorine molecules. Cl2 molecules are homolytically cleavage. Okay. So here, why this propagation step becomes prominent? Because since the concentration of Cl2 is higher in the mixture, the possibility of CH3 radical to meet a Cl radical is lower than Cl2 molecule. So that is why this step becomes prominent. But don't forget, this CH3Cl, the first product, can be formed either by propagation step or either termination step. The only difference is this would have the prominent dominant product, because prominent and dominant and abundant, because Cl2 is more often present in the mixture than Cl radical to have this collision with CH3 radical. Okay, so here they're asking about the propagation step. So this is a nice propagation step where when you have this CH3 radical, Cl2 molecules will come and form this one. Okay, and this is CH4 directly. So this will be attacked by Cl to form CH3, but this is not the correct one. It should form HCl. Okay, so this is indicates a propagation, but not the correct one. And there is nothing like this. HCl, when it forms, it's stronger. That's it. So it cannot be again broken back. Okay. So I hope you get the entire point about this one.